Okay, so one thing that we can look at when we had these simplified forms, the one thing that they had in common was that the leading coefficient, okay, the leading coefficient is a name given to the coefficient that's in front of your highest powered variable. So here your highest powered variable is x. You got an x squared. What's the coefficient? 1. Here, your coefficient, your highest exponent is your highest powered variable is m squared. Your coefficient is 1. And here as well, k squared, your coefficient is 1. So the one thing that they all have in common is that the leading coefficient is 1, okay? So we have a form, all right? We can just write it. We'll say that the form of a polynomial, if it's x squared plus bx, b is just some coefficient, plus c is just some constant, it doesn't matter, but one thing that you need to make sure, the only way that you can really use this technique is if there's 3 terms and that the leading coefficient is 1, meaning there's no coefficient shown there, so you know that it's a 1. So if you have 3 terms and the leading coefficient is 1, um, you will be able to factor it, okay? After you can find, we just need to find 2 numbers. We need to find 2 integers that they need to multiply to get your C, okay? And they need to add to get the B. Okay, so remember over here when we were talking about these numbers, where did this 5 come from? Well, the 5 came from multiplying these 2 numbers together. Okay, where did the 6 come from? The 6 came from adding those 2 numbers together. So when we work backwards, we're going to be asked to find what these 2 numbers are. And to get those, we'll ask ourselves, okay, what's 2 numbers that multiply together to get 5 and add together to get 6? Okay. Same here. Where did we get the negative 24? It was from multiplying these 2 numbers together. Okay. Where did we get the 2? It was from adding those 2 numbers together. So let's do an example. So we have x squared plus 7x plus 12. What are 2 integers that have a product of 12 and a sum of 7? Well, let's think about this. What numbers multiply together to get 12? Let's see. 2 times 6. Okay. We also have -2 times -6, right? You can always, a negative times a negative is a positive. We have 3 times 4. We also have -3 times -4. And then we always will have the 1 times 12 and then -1 times -12. So there's lots of pairs of numbers that multiply together to give you 12. But only one pair of these numbers will also add to give you a positive 7. Well, 2 plus 6 is 8, so that's not it. -2 plus -6 is -8, so that's not it. 3 plus 4 is 7. So these are my 2 integers, okay? And we don't even need to check any more of them, okay? I know that those will be the only 2 integers that will satisfy both of those things. So writing a list out of all the numbers that multiply together to give you your last term will help. It's not necessary, but writing them down can help, okay? So what are my 2 integers? My 2 integers are 3 and 4. So what are we going to do with the 3 and the 4? Well, when we factor this, x squared plus 7x plus 12, it's going to factor into 2 binomials, okay? And so both of the binomials are going to start with just an x, okay, since that's my variable, okay? And then where am I going to get my numbers from? So I'm not going to write a plus or a minus yet, okay? I don't know what they're going to be, not like in the differences of squares where we knew exactly which one was going to be which. We have to use the signs of these. This is a positive 3, so I'll write plus 3. And this is a positive 4, so I'll write plus 4 there. And that's it. You have factored your simplified expression of x squared plus 7x plus 12 into 2 binomials, x plus 3 times x plus 4. Okay. All right, let's work out some examples. Okay, so they do separate these into different sets. And the one thing that they distinguish between these are the signs. Okay, now some teachers might teach you, okay, how do you deal when you have two positives? Okay, what do you do when you have two positives here? What do you do when you have a positive and negative? What do you do when you have a negative and a negative? I'm not going to really differentiate between that. Let's see if we can build some connections a little bit. But as long as you remember that your two integers are supposed to multiply together to get your constant and add together to get your middle term's coefficient, then you're going to be fine. Okay, positive 20. Let's think of all the things that multiply together to give me positive 20. Actually, before I begin, I'm going to build my two binomials so we kind of see what's going on. So I know since this is a leading coefficient of 1, okay, that I'm going to have an n and an n there, okay? I don't know if they're pluses or minuses yet. Let's think of all the things that multiply together to give you 20. 4 times 5, right? Also negative 4 times negative 5. All right, 2 times 10, negative 2 times negative 10, okay? I have 1 times 20 and negative 1 times negative 20. Okay, so there's lots of different things that can multiply together to give you 20. But out of these 6 pairs, only one of them will add together to give you positive 9. Can you see it? Yeah, the positive 4 and the positive 5. So you just stick them right in there. Plus 4, plus 5. And that's it. So as always, you can check your answer by distributing, okay? Check if you distribute these two binomials, okay? If you distribute that binomial, will it give you, when you simplify, that initial expression, okay? All right, let's see, I'm gonna do number 4, okay? And I'm gonna leave 2 and 3 for you, okay? So you do 2 and 3, and I'm gonna do number 4. Okay, so I have a trinomial, meaning I have 3 terms. Tri means 3, okay? So 3-termed polynomial, we call them trinomials. I know since this leading coefficient is 1, I get to use this really quick shortcut way to factoring it, okay? And you're going to know why it's a shortcut, because in the next lesson, we're going to have to see leading coefficients that aren't 1, and there's a much longer way that you have to take. So this is the shortcut. So I'm going to put my y and my y right there. Now I need to determine what my two numbers that go into my binomials. So I think of all the numbers that multiply together to give you 1. Well, 1 times 1 is 1, and negative 1 times negative 1 is 1. But of those two pairs, I also need them to add together to give me a positive 2. My positive 1s, plus 1, plus 1. And we're done. So one thing to kind of note, guys, if you want to make these kind of connections with these plus signs and minus signs and everything like that, if both signs are positive, okay, if both signs are positive, both are pluses, all right, your integers will both be positive, okay? Both pluses, both integers will end up being positive, okay? So technically, if you had that in mind, if you knew that those were pluses, you wouldn't even have to go through in your mind the negatives. You wouldn't even have to factor those into play, because you already knew that if you have 2 plus signs in here, that both of your integers are gonna be positive, okay? But it's not necessary that you remember that in any way, okay? It can just help you have a shortcut. Okay, moving on. Now let's look. If you notice, it's a positive and a negative. That's what the kind of theme is here. You get a positive and then you get a negative. What's that gonna do to your integers? Well, let's check it out. Okay, so we're going to factor these. I got a trinomial, and since the leading coefficient is 1, I get to do the shortcut method. They're both going to start with an n. I need to figure out what my other two numbers are. I know that my two integers need to multiply together to give me negative 18. and add together to give me positive 3. Now think about numbers that multiply together to give you a negative number. A positive and a negative will multiply together to give you a negative number. So here, maybe negative 2 times positive 9 gives you a negative 18, or a negative 9 and a positive 2, right? Both of those pairs, if you multiply those together, get negative 18. You also have negative 3 and a positive 6, a positive 6 and a negative 3. We could also say 1 times negative 18 or negative 1 times 18, but I think I already found our pair of integers, okay? What's the second what's the second requirement of these integers? They have to add together to get positive 3. Well, negative 2 plus 9 is 7. Negative 9 plus 2 is negative 7. Negative 3, oh, I wrote the same one here, guys. Sorry, I meant to put the negative sign on the 6, right? Sorry. I pretty much copied the same ones from there to there. Okay, negative 6. Negative 6 plus 3 is a negative 3, so that's not going to work. I think this is our winner. Negative 3 plus 6 gives me a positive 3, okay? So if you always get a little tripped up with those adding and subtracting negatives, take your calculator out, okay? All right, so if you distribute and simplify, you will end up getting that original expression, okay? I will do number 8, okay? And I'm gonna leave number 6 and 7 for you guys to do. So I have a trinomial where my leading coefficient is 1, so I gotta do the shortcut method. I know they're both gonna start with a C, but I need to find those end numbers. So I think of two numbers that multiply together to give me negative 45 and add together to give me 4. Well, negative 9 times 5 is a negative 45, right? And then also negative 5 times 9 gives me a negative 45. Can you see one that adds up to positive 4? This guy right here, negative 9 and negative 5 and a positive 9. So if you decide to make a list and you see it right off the top, okay, if you see it right away, don't keep going on with your list. If you find it, just go ahead and write it down. I have C minus 5 times C plus 9, okay? Now there's other things that multiply together to give me negative 45. I could have kept going, but we found our winner, so we can stop there. Okay, let's go ahead and look at these other sets. All right, so here, what is the theme with this set? They're both minus signs. I guess we kind of did skip what happened here. What happened with these when we had a plus and a minus? Okay, when we had a plus and a minus, one of our numbers was positive, one of them was negative. Okay, so when we have a plus and a minus, my integers, okay, one will be a positive, one will be a negative, okay? But one thing to note is if you have a plus and a minus, what's going to happen is that your positive one is going to be the larger integer, okay? The larger integer. So you can kind of look at your examples that you did and see that. All right. So here, my theme is that we have minus and a minus. So what's going to happen? Well, so I've got a trinomial. The leading coefficient is 1, so I know they'll both start with an A, but what's my other two going to be? Well, I got negative 3, so I know a positive 1 times a negative 3, or negative 1 times a positive 3, and those are the only two pairs that multiply together to give you a negative 3. Now, here they need to add together to get negative 2, so that's going to be my winner, a positive 1 and a negative 3, okay? Let's do, I'll leave 10 and 11 for you, and I'm going to do number 12. So I'm going to go ahead and set up my binomials. They're both going to start with K since my leading coefficient is 1. I need two numbers that multiply together to give me negative 64 and add together to give me negative 12. Okay. All right. Negative 64. I know -2 times 32, okay? And similarly, -32 times 2. I also know that -4 times 16 and -16 times 4. I could keep going. I got -8 times 8, and well, it would if you switch it, they're both 8, so we're fine. But I think these are my pairs, and then also -1 and 64. But I think I see the answer. Okay, they need to add together to get -12. Right there. -16 and a +4. Now, what was the theme with this set? Okay, you had two minus signs this time. Okay, so what is our answers going to be? What are our integers going to be? Well, we're going to have a positive and a negative. Okay, a positive and a negative. So we'll have my integers will be a positive and a negative, but this time the larger of the, say the absolute value of the integers, okay, the larger one is going to end up being negative. Okay, so that's kind of the difference. And it's not necessary that you completely, that you know that and that you memorize that. But as you get better at this and the faster you get at it, it can help you do these more seamlessly. Okay. All right, my final set, the theme is that it's a negative and a positive. Okay, a negative and a positive. So let's see what that means with my integers. What will they end up being? Okay, so since it's a trinomial, I'm going to set up my two binomials, and it's a leading coefficient of 1, so it's going to be a very quick shortcut way. All right, so I need two numbers that multiply together to give me -24 or positive 24 and add together to give me -11. So let's see, I've got 3 times 8 gives me a positive 24. Also, -3 times -8 gives me a positive 24. 4 times 6, -4 times -6. Okay, I could keep going, but I think I already see the answer. This guy right here, right? -3, -8. Okay, I'm going to leave 14 and 15 for you guys. Let's do number 16. I got a trinomial where the leading coefficient is 1, so I get to do the shortcut method. Okay, I'm going to write my m's right there. Now I need two numbers that multiply together to give me positive 50 and add together to give me -15. Now you noticed over here, guys, both of my integers ended up being negative, right? I think that's going to be what happens over here. If you have a negative, a minus sign, and then a positive sign, what are you going to be able to expect from your integers? That they both have to be negative, okay? Let's see, things that multiply together to give me positive 50. I got -5 and -10. I could keep going on, but I think I already found it in my very first one. -5 plus -10 equals a -5 and a -10. Okay, so what can we say? If your expression has a minus and then a plus in that order, your integers will both be negatives. Okay, so like I said, if this doesn't really make sense to you, don't worry about it. It's really just a idea that can help you be quicker with factoring, but speed isn't necessary in what we're doing. So, all right, I'm going to go ahead and stop the video, and we'll begin in the next one.